Hello everyone. Greetings from Moscow, Russia AI meetups. Can you hear me? You can use chat or voice.
Yes.
Okay, great. My name is Dmitry Filatov. I am an ambassador for Pi and AI meetups hosted in collaboration with the Deep Learning AI. The year 2020 is coming to an end now, and Catholic Christmas is just in a couple of days. But this time the great festive mood is complicated with COVID fears and lockdowns of all sorts. And many people across the globe will not be able to meet and be with their dear ones because of safety precautions and health issues. So let's wish everyone to stay safe and healthy through these unusual times. And this is our final Pi and AI meetup here in Moscow for the year 2020. And tonight we will welcome Olga Megorskaya, who will help us to dive into crowdsourcing technology to learn how to prepare and annotate data for machine learning and deep learning projects. Olga is the head of Toloka.ai, a crowdsourcing platform developed by Yandex, which is sometimes called the company which is Russian Google. Hello, Olga. Great to see you, and thank you for joining us tonight.
Hi, everyone. Thanks for coming.
We really appreciate that all of you are taking some time for this event tonight. And before starting our conversation, I would like to say a couple of words about Pi and AI meetups and touch some housekeeping issues. Pi and AI meetups is an initiative launched by the Deep Learning AI. And these meetups help people across the globe to communicate, explore, and share ideas within the broad field of artificial intelligence. And the purpose of Moscow, Russia AI meetups is to integrate Moscow into the worldwide deep learning community and to provide space for opinions and experience sharing on AI topics, both on local and on international scale. Now just a couple of things, a couple of housekeeping issues. First of all, as I wrote in the chat, this event is being recorded, and there will be a link to the YouTube channel where this video will be uploaded within 2 or 3 business days. We will also share a version of presentation and a reference list with resources in the email after the event. There will be a post-event survey, so please leave a feedback. The link for this survey will be provided by the Deep Learning AI via email. And those who will complete this post-event survey will get a limited course promo code for 50% discount for first month subscription to any of Deep Learning AI's courses on the Coursera online platform. Questions and Q&A. Please use the chat to ask your questions either in English or in Russian. And Katya Fedorenko from Toloka.ai will help to answer questions in the chat. And we will do our best to answer as many questions as possible at the Q&A session after Olga's talk. And finally, if you have any unanswered questions or issues, inquiries, please feel free to email me at info@atakerina.com, and I will share this email address in the chat later. So with this, I will hand over to Olga Megorskaya. Olga, you're very welcome, and please start your presentation.
Thank you so much. I'll start sharing my screen. Okay, here it is.
That's all right, yeah.
Okay, thanks. First of all, thanks, Dmitry, for inviting us here, and thanks everyone for coming. Today, we would like to speak a little bit about the must-have expertise of modern AI specialists, which is related to data preparation for the training and validation of machine learning-based models. Couple of words about myself. I am the CEO of Toloka crowdsourcing platform, And for the previous 10 years, I have been responsible for providing the data labeling solutions for all products of Yandex. And today I would like at first to share some of our insights and experience from building the production and industrial pipelines for data labeling on the scale of Yandex. And then to share with you some insights about the methodology of effective usage of crowdsourcing, which can be actually applied not only by large-scale enterprises, but also by individual researchers and smaller companies and whoever is interested and working with the training of machine learning-based models. In the middle of my presentation, we will have a live demo and my colleague Rosmi will show you how actually the data labeling works in real time. So we'll be able to see the actual process and collect some labeled data within some minutes to see the magic of what is going on there. And also I will show you different use cases and business solutions which can be solved using the power of the crowdsourcing. So firstly, I'd like to start with some historical background. As I said, for the previous 10 years, I've been working for providing the data labeling solutions for Yandex. And this period could be divided into, I would say, two parts. Because initially we have been building an in-house team of so-called assessors, so people who have been employed in Yandex and have been labeling some data for the needs of internal teams of Yandex. And since the year 2015, we have switched towards the open crowdsourcing platform Toloka, which is used not only by Yandex, but is open for any requester and used now by hundreds of different companies and requesters from all over the world. And this actually switch is very interesting, and I'd like to share with you some of the thoughts which we observed while we passed this transformation. In general, Toloka is an open crowdsourcing platform where requesters and performers meet. We call our performers Talokers because they perform tasks on our platform. Actually, requesters are any companies or individual researchers who need some data to be labeled to train or validate their models. And Talokers are simple people from anywhere who can register on the platform and choose the tasks which are interesting for them and perform them and earn some piece of money. The Taloka word itself is an ancient word of Slavic origin, and it means like the commune and common job when people gather together to perform some big job to be done.
Yeah, that was my question. What does it mean, Toloka? Even I'm Russian, but I don't know this word.
It's very ancient. I didn't know it either before we decided to name such our product. But we like it because it reflects the whole idea of the crowdsourcing, which is a specific approach to designing a business process. When you have some huge task, you divide it into small pieces and send it to a pool of independent performers. Each of these people or each of these performers makes the smallest effort and performs a very small part of the huge task, but then their efforts taken together result in the solution of these higher level tasks. In the ancient period, these were like tasks, for example, like harvesting, or I don't know, when you needed to repair a church in the village or something like that. That's when people gathered together to perform some big task. Nowadays, the world is changing, and now the crowdsourcing is applied in the tasks related to the development of AI. And Toloka, since its launch in the end of 2014, has been growing constantly, both in number of projects which are available on the platform and in number of active performers who are available there. We expect to finish this year with more than 6 million people who are actively performing and earning some money on the platform.
So that's quite impressive. 6 million is a big number.
Yeah, it actually is. It actually is, and the recent year we are expanding really fast, and we are growing really fast, and we hope that this growth will not end and will only continue. But I'd like to step back a little bit to the 5 years back to the year 2015 and show what we have been observing there, which was actually a quantum leap in the machine learning production, which we observed while we moved from the in-house solution when we had some fixed amount of people who were performing the data labeling tasks towards an open platform where millions of people are available and freely choose the tasks which they want to perform. And you can see that comparing the end of 2013 and the year 2017, when the Toloka platform has already been using for like 1 or 2 years, we see the fantastic growth in every aspect, in number of projects which are being launched on a platform, and every project means some product for which the data labeling is collected, and the number of performers who participate in data labeling, and the number, of course, of the tasks done. But what is, and the idea of this quantum leap actually lies in the difference between what we call like the expert approach towards organizing the data labeling tasks, where you take some limited number of specially selected performers who are specifically trained towards the crowdsourcing approach, when you have a very formalized and decomposed process, which is decomposed into several smaller and simpler steps. Each step is followed with specific loops of quality control. Some of the steps are automated, and with that you obtain a measurable and scalable production of data labeling, opposite to the expert approach, when it works fine only until you need to scale it up. But when you need to scale these experts, you would find many problems, because it would be very expensive, actually unmeasurable, and hard to scale. So this switch from in-house to labelers to the open platform, and the switch from expert approach of data labeling towards the crowdsourcing approach, actually resulted in that quantum leap of production of machine learning products at Yandex. And what is even more interesting, and I guess if there are machine learning engineers and data scientists who are listening to us now, this is what I would like to emphasize, that actually what we also observed is that for Yandex, this transfer from the managed service towards a do-it-yourself model, when any engineer can come to a platform and set up a process for data labeling by herself, brought us 2 major changes. One is quite obvious. It's administratively much easier to provide easy and on-demand scaling of production of data labeling. But apart from that, and what is more important, this is a transfer in engineering culture, because it gave the engineers the opportunity to impact on every stage of AI production, starting from the very beginning, from the data gathering. If previously, before we had Toloka, and our engineers have been using like the managed service, the sphere of responsibility of AI engineers started only from the moment of training the models. And the previous step of obtaining the training data was out of their responsibility, and their attitude was like, I don't want and I don't have time to deal with it. Just bring me the labels of the perfect quality and I don't care. I am the great engineer. I want to think only about how to train a new model. And actually, this is the approach that we still see sometimes, and I still meet it sometimes among the data scientist community, although I observe that such attitude is now decreasing and moving towards the new understanding that actually the whole process of AI production is the sphere of responsibility of the final AI product and should be under control of the person who is creating this product. And once we have turned to this understanding, it brought us to the very interesting switch of the mindset of data scientists and the engineers, because instead of saying, oh, I don't want to deal with data labeling, it's not something I want to waste my time on, they started to think, okay, let me think of a more creative and efficient way to do this, and how can I, staying within the same budget, collect more data, or how can I collect data faster or something like that. And this is one of the, I would say, very important thoughts that I would be happy if you take out after this webinar, is that, well, in Kaggle, you compete within a given data set and you may not care where it comes from and how it has been collected. But in real world, the solutions compete within the whole pipeline of machine learning production. And actually, those who know how to manage the whole process of machine learning production, they get a strong advantage. I would provide a simple example of how one of the pipelines for continuous machine learning improvement may look like. There can be, of course, different configurations, but this is one of the standard ones. For example, you have the pool of training data and you have some production model which is constantly working to achieve your business goals. And then you have a team of data scientists and engineers who are constantly working for creating new versions of the algorithm to improve it. So first of all, you would need to constantly understand the actual quality of your model in production, because there may be different cases. There may be the context switch, maybe the data switch, something is changing in the surrounding world, and you need to make sure that the model you are using is still providing you the correct output. Secondly, you would need to understand whether the new versions which have been invented, the new versions of the model, are actually better or worse than your production model. So you would need to somehow evaluate them, and most often this can be evaluated, well, so-called offline, so using the human labels to understand, to calculate the accuracy and precision and recall of the model. You would need some data labeling. In some cases, for example, in online services, there may be additionally used some online evaluation and A/B testing and something like that. That is not necessary and not applicable in all the cases. But anyway, the model which outperforms the production in terms of offline or online metrics then becomes a new production, and the process goes on, and such a working pipeline can provide you the continuously improving AI-based product. And if we simply count the number of blocks in this scheme where you would need human labels, you would be surprised, because you need them to collect the training pool, you would need them to calculate the metrics of the quality of your production, and to calculate the quality of your new versions of the models. And even roughly counting the number of blocks, you would see that 50% of the whole AI product production actually depends on human labeling. And also this scheme shows us another outcome, that there are two quite simple and trivial ways to improve the quality of AI product. First, by gaining more training data to train better models. And secondly, to faster validate and implement new models and new improvements of your production models. And if you do those both things, you may be pretty sure that your product will be constantly improving. But to achieve this, you need to have a scalable data labeling production, and data labeling should not be the bottleneck in your machine learning production process.
Can I ask a question? Is there any limitation what type of data your customers can work with, or they can work with audio, text, and everything?
Thank you for the question. It's a very good question, and there are no limitations. I will show different use cases of collecting and annotating data of different types, and video and images and text and voice and whatever there is. Please stay with us and I will show you that. And that scheme that I've been describing of a constant improvement of AI product using the scalable production of data labeling has been proven its effectiveness within a variety of products, both within Yandex and by other customers who are using crowdsourcing to obtain the labels data. As of now, Toloka has grown up to 8 and even more right now, 8 million registered performers who can perform tasks on the desktop and on the mobile, on iOS and on Android. And we cover more than 100 countries, and the representatives of Toloka crowd speak more than 40 different languages. And actually using such a global crowd has a certain number of advantages. First of all, this is the production which works 24 hours, 7 days a week, because if you have so many people, that means that at every moment of time, there is somebody on the globe who is ready to perform your tasks. And you launch a task and pretty much immediately it starts to be performed. And it is really something that can be only achieved when you have this global and really big crowd force. Secondly, there is a very strong advantage of using the open crowd because it gives you an opportunity to get in touch with the collective wisdom of millions of people who live in different regions, speak different languages, have different hobbies, have different background, and they all are experts in some spheres. So you can really get in touch of very different fields of expertise when you need one. And finally, there is the ability to scale and shrink, which is often important when you have, well, I would say unstable production, which is quite often the case for machine learning. When at first you need a lot of data to collect the initial data set, but then you suddenly don't need so much. And it's not a problem on the platform because you just reduce the number of tasks and performers switch to the tasks of another requesters, so they don't left alone without any tasks, and vice versa. If you need to substantially increase the production of your data labels for some reason right now, that's also not a problem, just there are many people who would just join your tasks. Right now, we have the crowd force distributed all around the world. Of course, we started from the Russian region, but already we are expanding, and more than 1/3 of the population of our crowd is global, worldwide. We have lots of people in Asia and South and North America and Africa. We are now targeting to Europe. And within the nearest months, I would say that we would cover most of the countries in the world.
Can I ask a question?
Sure, please.
There are other big players like M2 or Lionbridge on the market, and they use similar business approach and principles to data annotation and crowdsourcing. So what is Toloka positioning in respect to other players? For example, I am a data engineer or a person who works in AI, and I want to have this service for my project, and I can now select at least between three of players, right? M2, Lionbridge, and Toloka. So what is Toloka compared to others?
Well, actually, I would say that as ourselves, we would be happy to be using Mechanical Turk if it worked for us, but it did not, so we had to create our own Toloka platform. In general, all the engineers and data scientists who compare us with the MTurk, for example, they see several major differences. First of all, in the product side, well, Toloka is a more modern, I would say, it's a crowdsourcing platform of a new generation in terms of the available tools for quality control, which I will speak a little bit more about them later, which are not existent in the MTurk, for example. Secondly, this is the global coverage of the workforce. For MTurk, many regions are not available for the performers. And thirdly, and I would say that this is becoming more and more important, is the attitude towards the performers. And many people who compare MTurk and Toloka see the difference in, for example, the tasks for the performers themselves. Like, we care a lot about how performers can choose the tasks from the wide range of available tasks. We care a lot so that the tasks interfaces for them are very convenient, so they can spend more time on a platform and provide better quality. So I would say these are the major differences. Of course, apart from the price, which is usually lower on the Toloka platform, but not because of the lower level of pricing, but because of the smart tools of quality control and aggregation of the results, which allow us to obtain a better quality using the minimal and even irregular efforts of many, many people. I would say like that. And Lionbridge, as far as I know, is more devoted towards translation tasks or relevance evaluation tasks. And I personally have never treated them as a universal crowdsourcing platform. But I would be happy to discuss that later on the Q&A sessions.
Yeah, thank you. Actually, the world is very connected still. Even though we have COVID, and if you work in Russia and you have several projects, one in Russia, one in Europe, and one in, I don't know, Africa or Asia, you can now select from these at least 3 players, and definitely you can choose the best one for yourself, and you can just compare them. There are a lot of information. And after the session, I think people will be able to read more about Toloka and be more sure how to approach your case.
Yeah, actually, that's good that you mentioned that. And we have lots of use cases right now. The world is really tightly connected and global. And in many cases, our clients have the need to launch the same project on several languages, like to collect similar tasks in Russian, in Chinese, in English, and in Spanish, for example. And Toloka is now developing this multilingual solution where you can once create a project and then automatically translate it into several languages and target it to different performers in different countries. And this is going to be launched in January. So if I'm not sure if other platforms also support this solution. It's good that you mentioned that. But actually, what I would like to point our attention to is the mathematics and smart tools which lie in the background of this technology, because crowdsourcing is not about giving very cheap tasks to millions of people. It's about how to use smart algorithms to achieve useful signal out of these minor efforts of millions of people. And the good news is that there's quite a stable methodology of how to effectively manage the crowd. And there are, well, I would say 6 steps if you follow them. And Toloka has tools already integrated into the system to easily support all of them. And if you follow all these steps, you may be sure to obtain a good quality at a large scale. And these steps would be the decomposition of the tasks, which sometimes is unobvious at the beginning, but lots of the research and practical evidence says that the better we decompose the huge task into a set of separate and smaller tasks, the better the outcome would be. Secondly, there are different tools for selecting performers, training them, and targeting the tasks to those performers who would be the best to perform your tasks. Then there is this whole family of quality control tools, instruments for motivating performers, and mathematical models allowing to aggregate raw data to obtain the final verdicts of the high quality. I would briefly describe in general the quality control tools are quite understandable. These are control tasks or honeypots, like tasks for which you know the correct answer and you inject like 10% of such tasks into your data set. And the platform automatically verifies if the person is constantly failing to provide the same answer as you expect on the honeypots, then probably we can extrapolate that his or her quality is not very good on the whole data set, and we can remove him or her from this task. Then the basic approach of the crowdsourcing usually says that we should use overlap, meaning that the same task can be sent to several independent performers, and then we automatically monitor their consistency with each other. Then, as I've said, there would be some tools for pre-selecting performers and also tools for post-verification when the task is quite difficult. You may give one task to one performer, and then create a pipeline of post-verification when at the second stage, other performers are asked to verify whether the task has been done correctly or not, and depending on that, the task is either accepted or rejected. In general, the idea of the training of people at a large scale is quite similar to the idea of training models in machine learning. You should set up such a process when you would spend the same amount of time on training many people as on training one person. And actually, it works pretty familiar to you if you're a data scientist. You would have some theoretical materials, then you would show many examples as a practice so that people can train their internal neural networks to understand the logic of a task. Then you validate their understanding using an exam task, which consists of the pre-checked tasks, so you can automatically calculate their accuracy on the project. And as the outcome, you get trained performers who would be guaranteedly performing with a good quality on your project. And aggregation of the results is the whole quite a big sphere of scientific research. Still, like every year, the new papers are posted on the topic. Still, people are trying to find more and more efficient models of aggregation of the raw results. When we send one task to several people, they provide different answers, and we aggregate their results, taking into account the expertise of each performer and their previous performance and our estimation of their future accuracy to understand which vote should be weighted higher or lower. And the same mechanics actually is used for what we call an incremental relabeling, when you on the run, the system would define how many more people you would need to ask in order to obtain the desired level of quality. For example, you would need to ask 5 people with standard expertise level, but if 2 people of higher expertise already agreed on the same label, for example, then probably there is no need to ask for the 3rd and the 4th and the 5th performer, and you can stop right there. So as I've said, just following those steps, you can make sure that the quality of the labels as the outcome would be good. And here I would like to get a small break to switch to the real life demo from Rosmi to show you the idea of how it actually works. And then we'll move to the real life business cases of implementation of the crowdsourcing. Please, Rosmi.
Thanks for the time. So today I will talk about a very simple, like usually is computer vision type of problem. I'll do a very small demo on image classification. So here I have a data set, well, just so it looks tidy. I have a data set that contains links. These pictures are either dogs, cat, or some other animal. So judges are supposed to, our Tolokers are tasked to differentiate this 3 classes, a dog, a cat, or something else. So here is our platform. This is how it looks like when you log into a platform. I will just start by creating a project from the very start. So I'll name the project. Is it a cat or a dog? So this will be something our on the platform, and when they select the object, they select the task, they sort of look at this name. So I just by saying decide what is on the picture. I'll save this section, then go into our task interface. Here we have a few options on how to do that. You either do it HTML or JS, or here I'm going to do our new JSON type that is very easy to use. So I'll just do view. I want to do a list. I want to insert an image, and I get that image from a URL that is a data input that I name image. I can preview this. I'll type image and put a sample link. So I have a sample link somewhere, and I know it looks like that. Then I think I don't need this part. We'll change this into something else. It's not view text, but I want a group of radio. Then I will add the label there. I will have few options. I'll do it like that. Actually, I will decide on what is the label. What animal is on the picture? This is radio. I'll actually change it radio group. I will remove that and have options where I have labels being decided, and this will be a data output that I call result. Then I will sort of, as agreed, we will have 3 classes there. So 3 classes. I'll call the first one cat. Send cat as an output. Second one is a dog. Third one, the output will be others, but I may want to label it differently. So I'll say when it's both, when it's unclear, when it's animal, or when it's not an animal. Not animal. I will close this section because it's already done. I'll try to submit something. This shows that we're sending result. When it's others, it's others. I have a problem there that there's no validation when it's empty. Then I just add another thing there. The validation that it's required. And I want to put a hint. You need to select an option. Now I'll try it again. Now there's a warning that I need to select this. And I want to sort of change the size of the screen. And I make it smaller, a bit bigger. So the task looks like that. I'm sort of done setting that up, so I'll save that. And I'll have a small option for the performers. I'll just copy paste that to not bore you. So copy paste it there, maybe put some enter here and there. And I preview it. Looks okay. I save this. There I have a project where I have it on what is the interface, how does it look like, what is the task. And now I will create a pool. What is a pool? It's somewhere where we decide on the price of the assignment. I will filter the task to be of, we have lots of filter here. You can pick language, device type, education, and so on. Here I will just have a very simple filter that because my task is in English, I'm doing English. Then, as Olga mentioned, there are many quality control rules here that we can put in place. I'll just, because the assignment is quite simple, actually I'll show you one, how it looks like, control task. It's very customized, like if there are more than four control task answers and the correct responses is less than 75%, I will just suspend Loker in pool for 1 day. This actually remove the performer from the pool because the task will be done very quickly. I'll show you. Or you can do other rules that filters out bots, for example, fast response. So what I'm doing here is I want to tolerate any fast response, and I set that per page of tasks that it has to be done at least within 10 seconds. Below that, I will suspend the performer for 1 day. Fast response. I will set an overlap of 3 to get sort of the majority later. And because the task is simple, I will have 90 seconds for task. There, I'm done setting things up. I will just upload the file where I put 9 tasks with 1 control task. This is my file. I upload it. Here I have 120 tasks and 12 of them is control tasks, or 10% as advised. Save this. And after this, we're actually done, and I just have to run this task. Now, while that is loading, it will actually happen quite quickly. For some reason, it's not running yet. I think it's with my internet, but let's see. I'll try to refresh the page, see if it's already running. No. So I think the screen is showing that I don't have stable connection, so bear with me, that is not really running.
Rasmi, if you have any problems with the internet connection, we can switch to the examples and the use cases, and meanwhile you will launch a project, and when we are back, you will show us the results. What do you think?
Run. So that will run in the meantime, and in the meantime, I will preview how this looks like for our so that
okay,
have like 10 tasks to be done. If they just submit it, it will not work. So they need to sort of select, it's a cat, it's a cat, it's a dog, it's a cat, it's a dog, it's a cat, that's a dog, the cute cat, it's a dog, and it's a cat. Then that works. So while that is loading, you can see that actually half of the is already done. So blue here means like some of our Tolokers are doing the assignment and the rest are actually done. So this typically happens quite quickly. Again, as Olga mentioned, we have lots of performers doing this in the platform. So 83%, and in the meantime, I can do how assignments look like. So this is one task, see how our judges are performing. They know it's a lion, they're not cats or dogs. It's a cat, it's a cat, it's a dog, it's a dog, it's a dog. So they are quite accurate. And I will just go back to the pool to see if we are complete, almost there. I'll just refresh it one more time. And in the meantime, show you our statistics dashboard. So you can measure quality by control tasks. So far, our forecast on the quality is 97% based on the answers of the control task, the 10% questions that we uploaded, the 12 questions. So we have many other things here on the dashboard, number of assigns, price, and so on. But because we're only running one here, it's like only a dot. Typically, it's a beautiful graph, I assure you. I'll go back here and it's actually almost there. So it's just one more performer. There is a picture of a cat or a dog.
Maybe, Rasmi, we would switch to the real use cases, and meanwhile you do the aggregation and share with us the results. How long did it take to label the whole pool? What was it? 3 minutes? How was it?
So far, I will probably share that statistics one. It's rapid, so it will actually show somewhere there. So yeah.
Okay, then I will, thank you very much. I will come back to my presentation to show, of course, this was the super simple example of a task of labeling cats versus dogs, but I will show you some real life use cases, because the crowdsourcing is a super universal and powerful instrument for actually solving different data oriented tasks. For example, I would roughly split them in 4 groups. This is the gathering of content when you don't have any and you need to collect it from the beginning. Then this is data annotation. Then these are business decision-making solutions and the generation of content. So we'll start with the first one, the content gathering. For example, quite a classic task and which is being very popular now among different requesters on our platform, is collecting voice recordings. For example, there is a voice assistant called Alisa, and she knows, she activates when she hears her name. And in order to train the model to activate correctly when a person pronounces her name, at first, the engineers needed to collect thousands and hundreds of thousands of records of the real people's speech said in different voices, in different environments, saying the same phrase like, "Hey, Alisa." So the task can be very easily done using the crowdsourcing. When we ask thousands of people, please record a very short phrase, say, "Hey, Alisa." Then we have a second step of verification whether the needed phrase was pronounced, and if everything is good, then we collect those recordings and within a very short time obtain a huge data set for these voice recordings. Or recently we've had a very, I would say, funny use case of using the crowdsourcing to verify the accuracy of the weather forecasts when people in different regions were asked to look outside of their windows and to like vote which is the temperature outside, which is the weather outside, and how does it feel like outside. And they, in order to verify the results, there was required a photo proof. For example, if the person states that it is raining, he or she would need to provide a photo proof that indeed it is raining right now. And by sending this task in an overlap, so that several different people in the same region would answer the same question, this information was used by one of the weather forecast providers, to verify the accuracy of their forecasts. Another interesting use case is called spatial crowdsourcing, when people are asked to come to a certain location offline and perform some task somewhere. For example, to update the information about an organization, like they need to come to a restaurant and take a photo of their working hours to make sure that the restaurant really works. It actually became quite actual during the pandemics, when many restaurants got closed even without any announcement about that. Another option is to verify some, for example, prices and goods inside the shops. Or, for example, here you may see how actually the task looks like for the performer when there are many tasks available on the map and you choose some task. For example, there was a task to verify some organization, but the system automatically verifies whether you are located near this point or not. And here there is a showing red button saying that you are too far away from the requested point, so you cannot submit this task. This is kind of an auto verification that the people are doing the tasks correctly. And such tasks are also used in many very interesting use cases. For example, there was a project for ecological monitoring when people were asked to come to a nearest trash container and take a photo whether there is a place for separate collection of trash or there is not. And under these tools, there is kind of a pipeline which contains several steps. As I have mentioned, there is an automated verification of the GPS coordinates and comparison of the coordinates of the person and the location. Then there is a multi-step verification that the photo has been taken actually correctly, that some information can be gathered out of this photo. For example, the working hours of the organization, or the name of organization, or something else. Another kind of tasks related to gathering of content is, for example, search for the objects in the internet. In many cases, it is quite hard to automatically parse all the objects of a needed type from the internet, and many requesters use Toloka for like this manual search of certain objects, and for example comparing the prices for the same object in different marketplaces. Then there are use cases of, for example, facts extraction, when people are given, for example, a piece of text about certain person, and they are required to extract some needed facts out of the whole text, which is quite a popular right now tasks for the industry related with the semantic search and other related tasks. There can be other interesting examples. For example, one of the requesters have been collecting photos of electricity counters from people's homes, because later they have trained the model and created an app which automatically extracts the data from your electricity counter and then proceeds some further operations automatically. But as a first step of this product, you needed to collect this data, and then there where Toloka helped. Or another very funny, I would say, project was from one of our requesters. They have been creating an app for online trying on of some shoes or something like that. And they needed to collect a lot of 3D models of different feet of different people. So what they were asking is people to provide a short video of their own feet. And basing on these videos, they later have been able to create those 3D models and launch their app. Another part is related to more classical tasks like data annotation, something similar to what Rosmi has been showing you, when there is a bunch of objects that need to be somehow labeled, either images or texts or segmentation with polygons or many other things. There are cases of audio transcription, which are very popular right now when the Toloka is asked to listen to a very short piece of text and they need to transcribe it into the text, or NLP related tasks when people are asked to segment the text by different types of words and nouns, etc. Or validation of auto-translate. Actually, because we have such an international crowd, it is widely used for solutions of automated translation to validate which of the options of the translation is actually better than the others. Or, of course, there are many cases of moderation and real-time moderation and classification of content, for example, moderation of user-generated content like comments on the forums or reviews on the maps or something like that. And for the moderation tasks, the usual approach is what we call a human in the loop, because there the real-time solution is needed. And how it usually works, you have some automated classifier which returns certain level of the confidence. And in some percentage of cases, for example, with 90% of the cases, the automated classifier works very fine. But the last 10% and the long tail of the hard cases cannot be proceeded automatically with the needed level of confidence. And then those 10% of the hardest cases are sent to the crowd, who are specifically trained previously, and then they just have to answer quite a simple question, look at this, for example, comment and say whether it is okay or not, and it is sent in the overlap of several people. In some super hard cases, even the second line of moderation is applied, where super highly expertise people sit and they deal only with 1% of super hard cases. And this multi-stage approach actually allows to provide the real-time moderation with the SLA of several minutes, practically on any amount of the objects, because it is scalable due to the fact that 90% of the tasks are being proceeded automatically. And at the same time, it's very accurate because the hardest cases are verified manually by the people. In the same way, it can be used for example, monitoring the mentionings of different companies in the social media and many other things. Of course, quite popular tasks on the Toloka platform are related to computer vision, which is booming now, and so many startups are dealing with the computer vision. Everybody needs those segmentation tasks. One of the new trends, I would say, is dealing with the videos, for example, spotting highlights on the video recordings, where you need to watch the video and highlight the very specific moment in the video. The third group of tasks and use cases that can be effectively solved using the crowdsourcing is, for example, business decision making, for example, side-by-side comparison to choose the best options of the design. And it can be used for very, very different cases, like to choose the best stickers, to choose the best, I don't know, backgrounds for the browser, to choose the best icons, or to choose the best design of a new product, many, many different things. In many cases, it is hard to formally ask a question from the people, but it's quite easy to ask people to show people two objects and ask which one do you like better, left or right. And then if you ask the same question to several hundreds of people and you ask them to vote and also to provide their comments and insights, you collect a digitalized estimation of the preferences of the audience, and at the same time collect lots of insights from their comments, which you can use for your product development in future. Of course, quite popular are different surveys, providing the fact that you can target your surveys on a specific audience. Sometimes it can be useful. And probably the most advanced usage of the crowdsourcing, which is not so popular yet, but it is gaining popularity. I would say that this is something to the masters of the crowdsourcing, to those who know how to cook the crowdsourcing perfectly, is the generation of content. There can be different applications of that. For example, generation of advertisements, or generation of short descriptions of the films, or something else. The major idea here is that you create a multi-step pipeline. At every stage, you ask people to do quite a few things. For example, verify whether the site opens on yes or not. If it opens, so what are the keywords mentioned there, la la la. So you at first collect some data using the very simple and small steps. Then you ask people to write some small pieces of text, and then you create a super multi-step pipeline where different people, each of whom have prepared their part of the text, are verified for the accuracy, for the following of the guidelines, for the misspellings, for whatever. And then their texts are being voted using the side-by-side, and they're being compared between each other. And then the best texts are selected. Then they are merged into one text, which is later verified once again. And this is a really huge multi-step pipeline. But the outcome, once this conveyor has been set up, this is an ongoing production which can really produce some generated content on and on without a stop for weeks and months and even years. Okay, that's actually regarding the use cases and the variety of different applications of the crowdsourcing where it can be used. I don't know, Rosmi, do we have any updates on our data labeling?
Of course, it was actually completed a while ago, so I can share my screen. So this is the statistics as promised. So it showed there is everything was wrapped in 4.5 minutes, but bear in mind, it doesn't mean like when you have 10 times the data. So it was 120 pictures. If it was 1,200 pictures, it wouldn't take 45 minutes because you need to take into account that this was because we have limited tasks. Then the number of parallel people doing the task is also limited by the number of tasks. So 4.5 minutes, sometimes it's 2, sometimes it's 3. Then I can show you on average, they take 30 seconds to finish the task. We spent 36 cents there, and the final quality was at 97%. Then we have an aggregation model. This is where we do the majority vote. So if I download the file, this would be the result. So you have the lengths of the images. Then you have, this is the output from the performers. So then this is the confidence result from the aggregation model. So the 100% ones is because it's a control task where we have the answer. And the rest is weighted.
Sorry, I'm not sure you're showing this file if you're looking at it.
Let me try that things. Excel. Yep. Should work now. Yeah. So
Yeah, we see it now.
we have things that is 100%, 97%, 99% or something. And this is basically an aggregation of first the majority vote plus the confidence our system has with the performer, and this is the result of the control task. So that is why it's not like 100%. So this 99% is probably all three judges did vote that this picture is indeed a cat, but the system is not 100% sure because probably some of the users failed one control task or something. And we see there's something that is 70%. Yeah. That's it, I think, that I have to share on the task.
Yeah, and actually, this is what thank you very much, Rosmi, for sharing. This is like we have shown you the very like full stage when we started from even creating the interface on our own. But of course, there are some presets for the most popular task types, so you don't need to type those HTMLs every time. But this is the feature of the Toloka platform is that it is very flexible and you can integrate your data labeling pipelines into your whole machine learning production process and then operate with this data in the way you need it. That's probably what we wanted to share with you, and we would be happy to answer the questions if there are any.
Can I ask a question first? I liked very much the demonstration and just want to clarify a couple of issues. Was it a real demonstration with random talkers selecting the real tasks which Rosmi just created in the system? Okay, it's quite very fast, very fast. But if we are talking about the real project, how long does it usually take to set up a project from zero? We're talking about middle-sized project, not a very big one, not a very small one. So how long does it usually take?
There are actually two parts. There is the part of how long will it take to like configure the project, right? What Rosmi has spent like 7 minutes, if I'm not mistaken, here. But usually, of course, if the average project would take a little bit longer, we usually recommend to try at first on the small data set to validate all the controls and settings that everything works correctly. So I would say it would take maybe several hours. Yes, Rosmi, please correct me if I'm wrong. Like this is a one-time investment into creating a project. And then if we speak about the running of the data labeling, I can come back. I had just informative slide about that because it is easier to look at the results. Here they are. So you can see they are pretty similar to what Rosmi has been showing, like 1,000 simple photos to be classified within 15 minutes is a real life case from Toloka.
Yeah, and the demo was on real random talkers. Yeah.
Yes, and one more question. If I have a person in my team responsible for working with data, so how long should I what time should I allocate to train her or him to learn how to work with your tools? So how long? Months, 1 week, 2 days? Give me
okay, I think Rosmi is the great person to answer this question because she has joined Toloka team when, Rosmi? 3 weeks ago, 2 weeks ago. When was that?
So I would say it really depends on the technical know-how of this person. But for me, so my background of education, I'm not technical. I like studied business, I'm an MBA, whatever. So I don't code professionally, but it took me really maybe a full week to learn everything. And that's when I learned like all the details in the platform. But our requesters that I talk to, typically their engineers take half a day to learn what's happening there, because what we're using are really basic. We can do Python, we have a Python client, so it works as per how Python works, and then JSON interface, HTML, JS. If you know all these things already, it's just all about looking at the interface and knowing which button is where.
Well, it's not too long, I should say. Quite fast. Okay, so we can now start the Q&A session. Correct, Olga?
Yeah, please. I see one question in the chat from Paul. What are your goals, metrics for the Toloka project, and how far is your planning scope? What do you call the success of the project at this stage? Paul, if you are still with us, could you please clarify whether you are talking about the Toloka projects, meaning our business as a platform, or meaning the project which is launched, like, for example, this data labeling of cats and dogs? And probably I failed to understand it correctly. But if I will, the whole Toloka project. Okay, thank you very much for asking us about our business and about the thing that we care about the most. Actually, our goal is, well, as I mentioned, we have started as an infrastructure, in a small infrastructural team within Yandex. And then we have within even Yandex search department. And then we have grown to become the major infrastructure for the whole Yandex. Then we have grown already to become the major provider of data labeling for all major Russian technological companies. And right now our ambition is to become the global provider of the data labeling. We are now having big contracts with some international and global technological players. That means that we have a constant demand for the global workforce. That means that we are right now inviting more people from different regions to our platform. So our ambition is to become a global crowdsourcing platform of a new generation, which on the one hand uses smart technologies to obtain the best quality out of minimal efforts of the people, and at the same time provides the deserved attitude towards the performers. And the success is measured in millions of dollars of our return rate by the end of the year. Something like that, as every business does. Every success of every business is measured in dollars. Yeah.
Okay, we don't have other questions yet. Last Pi and AI event was with Vision Labs, and as far as I remember, they are your clients, right? They're clients.
Yeah.
Can you give us a little bit information? What did they do? How did you work with Vision Labs?
This is a public case, and they have shared this by themselves. That's why we are happy to share that. Actually, they are constant users of Toloka, and if I'm not mistaken, they are using those anti-spoofing technologies, right? So they need to collect lots of images and video recordings of real people and the photos of the people in order to train their model to define whether it is a real person or a mask of a person or a photo of a person. And yeah, as far as I know, they have built up a constant pipeline for machine learning production, and Toloka being a part of it, an integral part of their production process.
We have another question in the chat.
For the independent performers, do you give access to the Toloka tool, or the performers they need to make his software tools? No, all the tools are available on the platform. Everything that you have seen from Rosmi's demo is available, so you can use it by your own. There is also a very flexible API. So you can use Toloka either from the interface, like Rosmi has been doing and showing everything in the UI, or if you are, if you find it more convenient, you can use the API and access Toloka just automatically out of there. But the conditions are the same for independent requesters or some big enterprise clients. Thank you.
Olga, we mentioned the new role, crowd solution architect. Okay. Could you tell us a little bit more about that? So, what is this role? Who can try it on? What is it all about?
Oh, thank you so much for the question. And I think we will share in the upcoming email or some materials, we will share some links to read and to look about this profession. Indeed, what we see is that as the data labeling is becoming an integral part of the whole ML process, there is a need of people in people who know how to build those business solutions based on the crowd. For example, how to solve those cases which I have described you in my presentation. So we have called this new profession a crowd solutions architect, because these are the people who invent actually from scratch the solution of some business need using the instruments of the crowd. For example, Rosmi is one of our CSAs, crowd solutions architects. Well, as Rosmi has mentioned, actually this profession fits for people with different background. Of course, the general technical advancement is required, but it's not like a super strong hard skills. In general, what I like about this profession is that this is a combination of some technical skills and business mindset, because what you initially need is to think of the whole solution. You need to design such a business process that will lead to the final solution of the high-level business need. And that is what makes this profession quite interesting for those who may be bored doing only purely technical stuff, or those who don't want to only do some managerial stuff. And this is the combination of the two. And we will share, we actually are preparing now the Coursera course, online educational course. We hope it will be launched in next year for those who want to learn more about how to effectively use the power of the crowd. Meanwhile, we are processing some educational tutorials on major conferences, and also we can organize some tutorials for the teams. Actually, if you feel that your team needs some of this education, we can organize a tutorial. We will send the links to some forms where you can apply for such training, which would be for free, and maybe give you some useful insights of how to develop both your business or your personal career. In general, all the information is under the site Toloka.ai. There you will see how to sign up as a requester and read everything and launch the projects actually. But we will follow up with more comprehensive materials later. Thanks for Dmitry about that opportunity.
Thank you. Olga, I have one more question related to data sets. When we work on projects, there are different type of data. Some data is proprietary, some not. So when we work with Toloka or similar platforms, how to deal with the confidential data? Is it like we can't do anything, or there are some kind of solutions?
Yeah, thanks very much for this question. There are several things to point out. First of all, according to Toloka's user agreement, all the data belongs to the requester. So Toloka as a platform does not own the data which is uploaded to the system. Secondly, there are mechanisms when you can even stay without uploading any actual data on the platform and keep everything on your own servers if you're more paranoid about that. We are actually moving now to the Microsoft Azure clouds, and then it will be even more transparent. The third part is about the data itself. And we always say that this is the responsibility of the requester. We have some monitorings to make sure that no private data is being sent to the tasks. But usually the general approach lies in the key of decomposition. For example, we have one of very interesting customers, the startup which is called dBrain, and they do a great job of transforming documents from scans automatically into digitalized forms, and they use the human in the loop combination of automation and people. But of course, you would never be able to send, for example, a scan of passport to the crowd because it's a private data. But what the guys do is they decompose the whole passport into separate even letters. So one letter from a document is not a proprietary data. So it is decomposed, and every crowd performer is doing a very small piece of job. Then they combine it back on their side. And this is a win-win situation. It is safe because the data is decomposed and it's impossible to collect it apart from the requester's side. And at the same time, it is performed even faster because you can parallel the whole process. So this is the general approach of dealing with some sensitive data.
Thank you. We have another question from Paul in the chat.
Did you do some research on your crowdsourced workforce, their preeminence, goals, work models, etc.? Yes, thank you very much for this question. Indeed, and we do care and we do invest a lot into knowing more about our crowd. For example, recently the new RIPS conference has just ended. I don't know if some of you has attended it or not. It was quite interesting, and Toloka has been holding a workshop on the topic of the crowd science, and one of the events during our workshop was a panel discussion where we invited all the actors of the industry. Like we invited the platforms like Mechanical Turk and Toloka. We invited the requesters from different enterprises. And we invited actual performers, the Talokers and M-Turkers, to listen to them and understand what are their needs and what are their concerns. In general, the working model of the performers is that the Toloka is an opportunity for them to get an instant source of some additional income, which does not force them to pay some regular efforts. So they just come and go. For us, it doesn't matter whether they come every day or once a month or even once a year. It doesn't matter, because if we use those smart tools for quality control, we can obtain useful signal out of their effort. And so the majority of people are those who just value this freedom and opportunity to perform tasks on the mobile or on the desktop when they are on the street or somewhere. Actually, that was very also, we noticed that during the pandemics, when people in some cases were forced to sit in some gloomy offices and risking their health, and Toloka was providing them an opportunity for some additional income without having to risk themselves and contact other people. Yeah.
Well, thank you. Any questions from the audience, please? Because we are coming to the end of our meetup. If there are no questions, we have to wrap up, I think.
Thank you so much. It was very interesting talking to you. You are very welcome to join our site, and if you have any questions, you can reach me via the LinkedIn or any other, like the website, and also Dmitry will follow up with the materials, which will hopefully you will find useful for you. Thank you very much.
I would like to say a big thank you to Olga for this event, for the presentation, and for Rosmi for the presentation of the case. It was impressive and very little time to set up a project. So now I know how to do it. I will review the video and do it myself, I think. So very interesting story about crowdsourcing these cases. Great. And thank you all for your time, questions, and comments. Just a kind reminder to fill in the post-event questionnaire. Please check your emails tomorrow, I think. Goodbye, everyone. Merry Christmas and a Happy New Year. Please stay safe. Bye-bye. Thank you.
Thank you so much. Bye-bye.